Hi everyone, good evening. First of all, thank you all for joining this session. My name is Sharat Nambia, and today we are going to discuss something very important for anyone who is entering the machining or the CNC field. Now, before I ask, let me tell you something. We might have seen many types of tools, right? We might have seen tools like end mill or taps, drill bits. Some people may get confused. So we had a student asking me a doubt. What are these? What are these? What are these differences? So that is the reason why I thought I will take the webinar today on this topic. Now, what will happen? People know the names, but when they go near the machines, their confidence will not be there. Today, my goal is simple. By the end of the session, you should be able to not just recognize the tool, you should also be able to understand why that tool is used or which tool has to be used there. And it will be always in your mind. So let's go into the session and let's start. Welcome you all again. When a beginner enters a workshop or a CNC lab, everything looks similar. You may see many tools arranged. Some are small, some are big, some have flat tips, some have round tips. But nobody clearly explains which tool is used where. And because of that, students usually do one of the two things. Either they guess and take it, or they will avoid the tool completely. They won't use it. Both are very dangerous. Guessing can damage a job, and fear will stop your learning. So today we are going to remove these confusions and the fear. We are going to make it simple, logical, and practical. First, before we start, what is a cutting tool? So most of the people may be knowing this, but I am just taking this in the beginner's level of. So let's start from the basics. What exactly is a cutting tool? A cutting tool is a tool that removes the material from the workpiece as chips. It will be removing the material as chip. When I say remove the material, it is not breaking, it is not melting. It is actually cutting and removing small pieces of material. These small pieces which are removed are called the chips. You would have seen this when the machining is happening. Small curly particles come out. These curly particles are known as chips. Now, very important thing, the cutting tool must always be harder than the workpiece. Cutting tool should be harder than the workpiece. What will happen if the tool is softer? I am using a material and my cutting tool is softer than that. What will happen? Instead of cutting the material, the tool will start wearing out and it will end its life. So always remember the golden rule: tool hardness must always be greater than the workpiece hardness. This is the foundation of machining. Always remember one thing. Okay, so cutting tools, it's used in milling, drilling, tapping, reaming. There are many cutting tools which we will be seeing today. And what are these made of? These cutting tools are made of HSS, it's made of carbide, it can be having some coating, all this can happen. Now, how machining works? So how machining works? Before we jump into different tools, let's understand what happens during the machine. Because once you understand this, everything becomes easy. Imagine this. You have a metal block and you bring a rotating tool near it. The tool rotates at high speed. It touches the surface and starts removing the small pieces. That is known as machining. So all tools which we are going to see today, they all follow the same basic principle: rotation, contact, and chip removal. The only difference will be the shape of the tool, the direction of the cutting, the purpose of operation. So don't get scared seeing many tools. Inside, all of them are doing the same designated job: remove the material. Now, one important thing: why do we need different tools? Why not use one tool for everything? Because in machining, we do different type of operations. For example, if I want to make a flat surface, that is one type of work. If I want to make a hole, that is completely different. If I want to make threads, that is again different. If I want a high accuracy, that is another process. So depending on the operations, we select different tools. So don't think now what is the tool first. First you have to decide what is the operation I have to do. Only based on the operation we should select the tool. So we have different types of operations as milling, drilling, threading, and finishing. Milling, I told, it's for removal of flat material, flat surfaces. We have to make the flat surfaces. Drilling for making holes, threading for making threads, and the finishing for making high accuracy parts. Now, we are entering into the actual tools now. We start with the most important one, the end mill. If machining tools were a team, the end mill would be the captain, because this tool is used in almost all the operations. Now, what is the special about end mill? End mill specialty is it can even cut from the side and also at the bottom. Because this is important, because some tools will cut only from the bottom and only in one direction. But end mill gives us flexibility. What we can do with the end mills? In the end mills, we'll be using it for slotting. We'll be using it for straight edges. We can use it for flat bottom slots. All these things we can use this end mills. Then imagine you are cutting a straight groove in a plate. You want clean edges in the bottom and flat bottom. There what we will do? We will use this flat end mill. Why? Because it will give a flat corners. Now just imagine, we don't want the flat or sharp. We have a 3D surface. A 3D surface. So can we use the end mill? Yes, technically we know yes we can use it. But what will happen? The result will not be good. If you want a 3D profile, a radial profile or anything like that, we'll have to use another tool which is known as the ball nose end mill. Okay, that is the ball nose end mill. Ball nose end mill, what we use it for? This is a very interesting tool. instead of a flat tip, as you can see in the screen, it has a rounded edge. Why this is useful? This is useful because imagine you are machining a curved surface like a mold or a 3D shape. If you use a flat tool, it will leave steps. You can get uneven surface. But with the ball nose, because of its rounded shape, it can smoothly follow the curves, and so the final surface becomes very smooth. That is why this tool is widely used in mold making, 3D contour shapes, contour machining, complex shapes, all those things. So always remember, flat is for the straight works and ball is for the curved products. Now, ball nose. Now everyone gets confused with the next thing and ball nose. Next is a bull nose. So everyone gets confused here. What is a ball nose? What is a bull nose? Sometimes in the interviews they may ask, what is a ball nose? What's the difference between a bull nose and a ball nose cutter? So there is nothing different much. This is actually we can even say it is like a combination tool. It's a bull nose end mill. It looks like flat, but will have a radius at its corners. Now, why we use this? We use this because flat tools have sharp corners, I told you, and sharp corners are weak. They can chip off easily or break. So by adding a small radius, we increase the strength of the tool. So this tool, it will give better tool life, less breakage and good finishing. It is commonly used in semi-finishing operations, finishing operations, etc. So if you want a balance of strength and performance, you will use the bull nose. Next. So let's simplify everything. Flat end mill is for flat surfaces. Ball nose is for curved surfaces. Bull nose is for when strength is required. See, if you want to machine a 3D mold surface, which we can use, we will use with ball nose. So always you have to connect the tool with the application. Next, roughing end mill. What is roughing end mill? Now this is slightly different. How it's different? If you look closely in the image, it has serrated edges, not smooth like the others. Why? Because this tool is used for heavy cutting in the initial stage of machine. When you have a lot of material to remove, we don't care about the finish. We care about speed. So roughing end mill will be used at that cases. What this end mill does. This will break chips into smaller pieces, thereby reducing the cutting force and allowing faster material removal. You can think of like a machine which removes bulk material first, and then we will use a small machines to finish the final finishing. Finishing tools will be used later. Next, we move to the face mill. This tool is used to machine large flat surfaces. Instead of one cutting edge, this tool has multiple inserts. So many cutting edges are working together. So what will happen? This means that the machining is faster, the productivity is better, all those things. Now imagine you have a big block and you have to make a top surface flat. A small end mill, using a small end mill, will take time. But if we use the face mill, we can do it much faster. So tool selection not only affects quality, but also affects the time. Before we move ahead, let's understand one important concept in modern machining: insert tools. Earlier, the tools were made as one solid piece. If the cutting edge wears out, the entire tool has to be replaced. That means more cost. Now, what industry does? Instead of making the full cutting tool, they attach small replaceable tips called inserts. So when the cutting edge wears out, you just change the inserts. The tool body remains the same. This gives us multiple advantages. What are the advantages? One, cost saving, less downtime, easy maintenance, all these things. So when we see face mills or some end mills, you will notice small pieces fixed with the screws. Those are the insert. Those are known as the inserts. So this is one of the biggest advantages in CNC machine. Now we move into the hole making. So hole making. First tool is the drill. Everyone has seen a drill. Even in daily life, most of us use. Now let's understand it properly. A drill is used to create holes. Drill is used to create holes. But what many beginners don't know is a drill is not a precision tool. It is a starting tool. If you look into the drill carefully, it has a pointed tip, helical flutes, right? So this pointed tips, normally the angle will be always 118, that is 118 degrees. This point, the point in the corner, that helps to remove the chips. If I drill a hole of 10 mm, will I get exactly 10 mm? That's a question some people have asked. In most cases, no. There may be a slight variation. So, surface finish may not be good. So, drilling is only the first step. So, if we need accuracy, we won't stop after drilling. So, first we use the drill bit for basic drilling. Now, what's the problem? Let's clearly understand the limitations of drilling. After drilling, the holes may have rough surface, slightly oversized or undersized, poor roundness. So if your job needs high accuracy, you cannot depend only on drilling. This is where beginners make mistakes. They drill and assume the work is finished. But in real industry, drilling is just the beginning. After drilling, for example, if your requirement is to insert a bolt, you need threads inside the hole. This is where we use tap. A tap is used to create internal threads. Now think about a nut. Inside you see threads. These are made using the tap. Now taps comes in different types. We have hand tap, machine tap, spiral tap, but the concepts are the same. It cuts threads inside the hole. Tapping always requires a correct hole size. If the hole is too small, the tap will break. If the hole is too large, threads will be weak. So the proper sequence and sizing is very important. What we will do? How we will calculate it? Normally we have formula 0.8 into D or 0.85 into D. That is why we use it. what will happen? For example, we have to drill a hole of 6 mm. If you have to drill a hole of 6 mm, theoretically what we will do? 0.8 into 6. That means it is 4.8. So we will drill a hole of, actual as per theory, we have to drill a hole of 4.8 and then insert the tabs. The tabs will be of 3 tabs. There will be a set of 3. The first tab, second tab and the third tab. So first we will be inserted the first tab, then the second tab and the third tab. This is from the hand tab side. Now, next is the reamer. This is the most misunderstood tool. Many people skip this completely, but this is very important. This reamer is used to improve the hole accuracy. What does that mean? So after drilling, the hole is not perfect. The reamer will improve the size accuracy, improve the surface finish, and make hole more precise. So if you have applications like bearing fitting or pin fitting or precision assembly, then the reaming is compulsory. So what is the difference? What is procedure for reaming and tapping? The difference. So for reaming, normally we give a 0.2 clearance. But if we have to do an 8 mm reamer, to use an 8 mm reamer, the hole will be 0.2 less, that is 7.8. We make a hole of 7.8 and then put the reamer. When using the reamer, you should make sure we don't rotate it to both sides. Even if it is inserting or removing, it should be always in the clockwise direction. You should not go anti-clockwise. Whereas in the tapping, what we will do, we will go clockwise for little time, then come clockwise. 2 times clockwise, 1 time anti-clockwise. 2 times clockwise and 1 time anti-clockwise. And in reamer, only it is direct clockwise. Then, what is die pass? A die pass is nothing but. Now we have talked about the internal threads. What about external threads, like on the bolts? These threads are the external threads are made using a thing called as die or die passing, we call it. Usually on rods or shafts when we make the threading outside. It is similar to tap, but direction is the opposite. Tapping is for inside and die passing is for outside. So next time when you see a ball, always remember this had been made used by a die. Okay, so you can see here there will be different die passes for different sizes, and then we'll put it in the holder and make the external thread. So if I have a hole inside and want to create thread inside, I use a tap. If I have a rod and want thread outside, we use die passing. Don't ever confuse between these two things. Now, process flow. How does it work? First, we will do. How we will do? First, we will drill. Then we will use a reamer if necessary, and then we will use the tap. This is the proper procedure. If you skip the steps, what will happen? You will face the problems. Because why? You cannot do the tapping without drilling. You cannot get the accuracy without reaming. So machining is not random. It is a sequence. And the understanding sequence what makes your profession. Next, chamfer mill. Now let's go to the finishing mill. Chamfer mill. This tool is used to remove sharp edges. So we say normally in the case of product design and everything, we say other than blade, no edges should be sharp. So here what we use, this tool is used to remove the sharp edges. Now many people think this is not important, but actually it is very important. Why? Because sharp edges can cut hands, create assembly problems, looks unprofessional. So chamfering is done to improve the safety, help in assembly, improve the appearance, and even a small chamfer can make a big difference. Next is the T-slot cutter. It's a special tool. Special tool. You might have seen this in the machine tables. The machines will have a T-shaped cuts, inverted T-shaped cuts. So these slots are used to clamp the jobs. Now, this special shape cannot be made with normal tools. So we use a T-slot cutter. It creates the undercut shape. This is mostly used in milling machine tables, fixture plates, or some clamping plates. So wherever you see a T-slot, remember that it is made of using a T-slot cutter. Next is a dovetail cutter. This is another special tool. This is made to manufacture angled grooves. Why do we need this? Because for strong mechanical locking. So that where it will be used? It will be used in the machine slides, tool holders, precision assemblies, and because of the angle, parts fit tightly and don't move easily. So this is used where strength and alignment are important. Now let's talk about some mistakes. Learning tools are not enough. Avoiding mistakes is equally important. Common mistakes beginners make are: first one, using wrong tool for operation, skipping the finishing tools, not following the proper sequence, applying too much force, breaking tabs. Machine is not the problem maker most of the times. It is the tool selection that is the problem. So always think before using a tool. Tool selection. Nothing to worry much. It's just simple logic. If you want a hole, use drill. If you want accuracy, use ring. If you want thread, use tag. If you want a flat surface, use face mill. That's it. Always match the tool to the requirement, and that's the easiest way to remember. So let's quickly summarize what we have learned today. We started with the basics. So we discussed what is a cutting tool. Then we understood different types of tools, end mills, their variations, face mills, roughing tools, drills, tabs, reamers, dies, special cutters, etc. But more importantly, we learned how to think, not just tools, but sequence, application, and logic. So next time you guys see a tool, you'll not be just seeing the metal, you'll understand its purpose. And that is the difference between a beginner and a professional. Thank you everyone for your time. I hope this session gave you clarity. If you have any questions, please feel free to ask, and keep learning, keep practicing. Our another information, our Open Education's batch number 5 is going to start on this 23rd of February. That is day after tomorrow. So if you guys are interested in joining, you can contact us. Almost 2 seats are remaining. Only 2 more seats are there to be filled. All the seats are complete. Now there we'll be teaching about CNC operations. We'll be teaching about SolidWorks. We'll be teaching SolidCAM. That is from beginner to a programmer. It's a 45 days course. You can always contact us for joining. Any doubts? Please show in the chats. I'll be here for 5 more minutes. and then we'll wind up. Thank you.